Hello students, welcome to Educate. In this video, we will discuss about nature of CX bond and about the preparation of haloalkane and haloarine. Let's discuss. First of all, nature of CX bond. You already know that the halogen is the most electronegative elements. Halogens are the most electronegative elements. So what happened here? So in case of haloalkane molecule, the hydrogen atom, suppose this compound here, the halogen atom attract this shared pair of electron towards itself. So there will be slightly displacement of this shared pair of electron towards the halogen atom. As a result, there will be development of slightly negative charge on the halogen and slightly positive charge on the carbon atom. As for example, when we take like fluoromethane, so there is actually bond formation. There is sigma bonding between the carbon and the fluorine. And during this course, since fluorine is more electronegative, so the fluorine atom attracts this shared pair of electron towards itself more extensively. So there will be slightly development of negative charge on the fluorine atom because this sigma electron slightly displaced towards the fluorine atom, and there will be a slightly positive charge on this carbon atom. So this molecule is polar because there is development of a positive charge and a negative charge. So haloalkane molecules are polar in nature because there is positive charge and the negative charge in the molecule. So haloalkane molecules are polar. So nature of CX bond is polar. When there will be polarity, then there will be dipole moment also. So what happened? The dipole moment is the product of negative charge developed on the halogen and the CF bond length. The dipole moment is the product of negative charge on the halogen and the bond length, or since the negative charge and the positive charge, the magnitude of negative charge and the positive charge will be same. So dipole moment will be also equal to the magnitude of this positive charge on the carbon atom and the CF bond length. So dipole moment here depends on two factors, that is electronegativity and the bond length. That is here CX bond length and the magnitude of negative charge on the halogen or the magnitude of positive charge on the carbon. That means dipole moment is equal to magnitude of negative charge or that of the positive charge into bond length, suppose X. X is, so dipole moment is magnitude of negative charge or positive charge on the carbon atom and into bond length. Okay, so let's see what would be the order of dipole moment. That's a question frequently asked in the NEET examination, and in the that is also important for you IIT main and the CUET examination. What will be the order of dipole moment? So order of that means in CS3F, CS3Cl, CS3Br and the CS3I, among these one you will have to write the order of dipole moment. What happened here when we consider about here this hydrogen. The dipole moment of CH3Cl is greater than that of CH3F because dipole moment depend on the bond length and the magnitude of negative charge appear on the halogen or the positive charge appear on the alpha carbon. So, two factors is responsible here about the dipole moment, that is electronegativity and the bond length. When we compare about the electronegativity, then the electronegativity of chlorine is not much less than that of fluorine, but the size of chlorine is very large compared to that of fluorine. So here, like CH3F, suppose here carbon molecule, fluorine will be smaller than that, and this one here. And when we compare about CH3Cl, size of chlorine is very large compared to that of bond length. So the product of the negative charge appear on the halogen and this bond length is very large, that will be larger than that of product of this negative charge on the fluorine atom and this bond length. That's why the CH3Cl possesses greater dipole moment than that of CH3F. So if we indicate them by this one 1, 2, 3, 4. So CH3Cl dipole order of dipole moment is CH3Cl is greater and then after is CH3F. Then after, when you consider about the electronegativity of bromine and iodine, you know the electronegativity of bromine is too much less than that of chlorine. Even though size is larger, but when we multiply, the charge appears on the bromine and the CBr bond length, then that will be lower than that of the charge appears on the chlorine and the CCl bond length. So the bond length of CH3, so the dipole moment of CH3Br will be lower than that of CH3Cl as well as CH3Br, and then after is CH3I. So exceptional here is that. So in the examination, question asked here frequently asked, a number of times questions has been asked, and when you consider about this question was asked in 2020 or 2021 in the give reason types. So what is here? The dipole moment of CH3F is lower than that of CH3Cl, and that was the reason was here. So that is here. So correct option was here there, that the electronegativity of chlorine is not very less than that of fluorine, but the size of chlorine atom is very large than that of fluorine. So the product of the negative charge appears on the chlorine and the CCl bond will be greater than that of the negative charge appears on the fluorine atom and the CF bond length. Okay, so here This one clear? That will you will have to write in the examination. Question may ask in give reason, so that's you will have to write that CS3Cl possesses greater dipole moment than that of CS3F, because the electronegativity of chlorine is not much less than that of fluorine, but the size of chlorine is much larger than that of fluorine. As a result, the product of negative charge, product of negative charge on halogen and CX bond length will be greater in CS3Cl compared to that of CS3F. So among fluorohalide, the CS3Cl will possess, among methyl halide, the CS3Cl will possess greatest dipole moment and the CS3I will possess least dipole moment. The dipole moment of CS3Br is less than that of CS3F or CS3Cl because their electronegativity is less. Same here, electronegativity of iodine is very less. That's why its dipole moment will be least. Okay, so haloalkanes are polar, and in that CS3Cl will possess greatest dipole moment and the CS3I will possess least dipole moment. There is anomalous behavior or anomalous order at CS3Cl and CS3F. Then after is here. So let's see, that was about this one. You may watch out here, verify here, dipole moment of CS3F is this much and that of the CS3Cl is that much. Then after, so here the dipole moment of CS3 is largest, highest dipole moment is of CS3Cl and that of CS3I is least. So when you compare about the dipole moment of CS3Cl, that is greatest than that of CS3F as well as CS3Br. The dipole moment of CS3Br is less than that of CS3F also. So about which I have already discussed, which is verified by here. So what happened, usually students try to mug up this one. No need to mug up what's the value of dipole moment of these compounds. In the examination, question will not ask what is the dipole moment of CS3Cl or CS3F. The question asked is only about the order of dipole moment or among this one CS3Cl and CS3F. The CS3Cl possesses greater dipole moment than that of CS3F. Why? Okay, about that the question only asked about that. Now let's see about this compound here, method of preparation. There is various method of preparation. First one is from alcohol, then after from hydrocarbon, then after here in a hydrocarbon there is alkane, and then after alkyne also. So about alkyne here not given. Addition of halogen. Then after is halogen exchange. In a halogen exchange, what is that? Preparation of iodoalkane and the fluoroalkane is very difficult. So to prepare the iodoalkane or the fluoroalkane, it is preferred to prepare the bromoalkane or the chloroalkane firstly, and then after do the halogen exchange reaction. So here this halogen exchange reaction is firstly you prepare the chloroalkane or the bromoalkane, and then after replace them by the iodine by suitable reagent, by taking the suitable reagent. That was about the haloalkane method of preparation of haloalkane. And here haloarine, that is one is electrophilic substitution reaction. Then after is Sandmeyer's reaction. Sandmeyer's reaction is too much important for you. And then after is here this chapter completed. There will be test question about which we will also discuss. So firstly, method of preparation of haloalkane by the alcohol. So let's see here. Already reactions is written, but I shall tell you how to do so that you if you have not studied this one, then you could write the product also. Guys, I shall tell you how to practice this question. When you will practice, then the reaction will remain in your memory for a longer period of time, and very conveniently you could write the product. But if you will try to mug up this reaction, a number of times you will mug up, and then after will forget also, and then after maybe you shall come in the pressure. So the manner in which I am telling you to solve this, how to predict the reaction, about that you watch out carefully, and then after you practice at your home also. Without practicing, if you will not practice, you will listen here, and then after will not practice, then the information will escape out from your memory. So better at least 4 or 5 times, at least 5 times you will have to practice that reactions, but not in a single days. One day, that means one day today, like suppose today if you are practicing, then you will practice after, that means tomorrow, then after 5-6 days, and after 5-6 days, like that. So 5-6 times when you will practice these reactions, then these reactions will remain in your memory. So let's see, and I think if you are a serious candidate, and earlier also you have applied a lots of effort, then might be you have realized that this keeping the product of the reactions is how much difficult. So now let's see how to these reactions. First one is reaction of alcohol with HCl and ZnCl2. The mixture of HCl and ZnCl2, this one is called Lucas reagent, and that is used. The mixture of conc HCl and ZnCl2 is called Lucas reagent, and it is used to distinguish the types of alcohol. That means the alcohol is primary alcohol, or the secondary alcohol, or the tertiary alcohol. That is predicted by Lucas reagent, that is the mixture of ZnCl2 and conc HCl. So let's see how the reaction is taking place. So firstly here I am taking directly from here. So let's see of this HCl, what happened? The hydrogen of HCl that combined with OH, so form H2O. So after the removal of H2O, this H2O form, after the removal of H2O, the carbon of alkyl part will become unsatisfied. That means their valency will not get satisfied, and that of the chlorine will also not. So this the carbon of alkyl part we bond to chlorine and form RCl. As for example, let's see this reaction. This one here react with HCl in presence of ZnCl2. So what happened? This hydrogen will combine with this oxygen, so it will release as H2O. Hydrogen will combine to this oxygen. Already one oxygen hydrogen was there, so 2 hydrogen and 1 oxygen combined here, that will become H2O. So valency of this carbon atom become destabilized, and that of this chlorine will also become destabilized. So this chlorine will get bonded to this carbon, so compound will become this one. So chloropropane here, in the same way here that will take place. Okay, the mixture of ZnCl2 and conc HCl, that is called Lucas reagent. Lucas reagent, L-U-C-A-apostrophe-S, Lucas reagent, and it is used to distinguish types of alcohol. In the box method you may write types of alcohol, that is primary or secondary or tertiary. Same as primary alkyl halide means halogen was bonded to primary carbon atom. In the same way, primary alcohol means OH will be bonded to the primary carbon atom. In the same way, secondary alcohol means OH will be bonded to the secondary carbon atom. And same as tertiary alcohol, means OH will be bonded to the tertiary carbon atom. Okay, the mixture of ConHCl and ZnCl2, that is called Lucas reagent. Now let's see next question about this one. Here, when alcohol react with the mixture of NaBr and H2SO4, NaBr and H2SO4, then what will happen? Listen here. Here I am taking the example, then after there you can also predict. As for example, I am taking here this compound. That's react with NaBr and H2SO4. So you know that the first dissociation constant of H2SO4 is very large. The first dissociation constant of H2SO4 is very large. So the H2SO4 will firstly dissociate into H plus and HSO4 minus. And the second dissociation constant of H2SO4 is less. That is in the order of 10 raised to the power minus 2. So compared to first dissociation constant, the second dissociation constant of H2SO4 is very less. So H2SO4 frequently dissociate into H plus and HSO4 minus. But the overall dissociation constant of H2SO4 is also large. Okay. So let's see here what is that. So H2SO4 here, this H plus will combine with oxygen. So that's become H2O. That become H2O. The sodium combined with HSO4 minus. The sodium of Na plus of NaBr combined with HSO4 minus. So that will become NaHSO4. Then after valency of this bromine will left and that of this carbon will also left. So bromine will combine to this carbon. So compound become so when the alcohol react with NaBr and H2SO4, so there will be formation of here RBr, bromoalkane, H2O and NaHSO4. Let's see the next reactions. That is about, let's see about this reaction. So when react with PCl3, PX3, either PCl3 or PBr3, whatever be that. So what happened? Let's see here this compound. I am taking off that means ethanol. This compound react with PCl3. The structure of PCl3 is like this. Here shape will be trigonal planar. That means the phosphorus atom and the 3 chlorine atom, like one here and one here, they will arrange, that means 3 chlorine atom will arrange around the phosphorus atom in the same plane. So when you will join the center of one chlorine atom, center of this chlorine atom and the center of this chlorine atom, there will be formation of a triangle. So this shape is called trigonal planar. That means there is formation of a triangle in a plane. So that will be called triangular planar. So shape of PCl3 is trigonal planar. So all this bond will be equivalent. So actually there be here 3 alcohol molecule. What happened? This chlorine atom will combine to this carbon. Same, this chlorine will combine to this carbon and this chlorine will combine to this carbon. So from this portion OH releases, from here OH releases and from here OH releases. In PCl3 there is 3 chlorine atom. So that 3 chlorine atom will combine with 3 carbon of the alcohol, 3 alpha carbon of the alcohol molecule. So from the alcohol molecules, since 3 chlorine will combine with 3 alpha carbon of alcohol, that's why 3 OH will release from there and they will combine with phosphorus. So there will be formation of 3 moles of here when they combine. So there will be formation of CH3, CH2, Cl. Here also there will be formation of CH3, CH2, Cl. Here also formation of CH3, CH2, Cl. That means 3 moles of chloroalkane form and the 3 OH of phosphorus will combine. So 3 OH, that means P, if you write this one. So that is actually written as H3PO3. So 3 moles of, when this one combine, then 3 moles of haloalkane and 1 moles of H3PO3 will form. When PCl3 will react with alcohol, then 3 molecules of alcohol will react with 1 molecule of PCl3. As a result, there will be formation of 3 moles of haloalkane and H3PO3. That is here same. So if you will have to write this reaction, that means if you will have to write a reaction this one, CH3CH2OH when react with PCl3. So what will happen? There will be formation of 3 moles of chloroethane and H3PO3. Here 3 moles of alcohol will react with 1 moles of PCl3. So there will be formation of 3 moles of chloroethane and H3PO3. That was. Now let's see when reaction takes place with PCl5. Watch out carefully. Same this compound here, PCl5 have trigonal bipyramidal symmetry, like if PCl3. So like this one, shape was there, and 5. So one chlorine atom will be above to that plane and another chlorine atom will be below to this plane. In PCl3, the shape of molecule be trigonal planar. But in case of PCl5, on that trigonal planar geometry, one chlorine atom will be above and one chlorine atom will be below. So from all the 3 chlorine atoms, when you will join the above chlorine atom and that of the below chlorine atom, so it will appear that there is formation of 2 pyramid above and there will be formation of a 1 pyramid above and a formation of 1 pyramid below. So 2 pyramid joined together, of which the base will be triangle. So shape will be called trigonal bipyramidal. Okay, of this trigonal bipyramidal geometry. So of this PCl5, the chlorine atom which is above and which is below, their bond length will be greater. So bond dissociation enthalpy will be less. In PCl5 molecules, the chlorine atom which is above to the plane or below to the plane, that will have greater bond length and hence the less bond dissociation enthalpy. So the chlorine atom which is above and which is below, that will dissociate very easily. Okay, compared to that of these 3 chlorine atom which is present at the plane, which are present at the same plane, this chlorine will not dissociate. Only the chlorine which is above and which is below, that will dissociate, since their bond length is greater and bond dissociation enthalpy is less. So what happened? One chlorine combined with hydrogen, so form HCl, and one chlorine will combine to this carbon. So there will be formation of CH3, CH2Cl and HCl. Oxygen left from here, that will combine to this phosphorus. So there is already PCl3, and when oxygen will combine there, so there will be formation of POCl3. So that become. That means when alcohol will react with PCl5, then the alcohol will react with PCl5. There will be formation of haloalkane, the HCl and POCl3. Okay, guys, very easy it is. Now let's see. Guys, the concepts which I am giving you here, that is based on the concepts which you will have to study. So these concepts are not useless. These concepts you will have to study later on also, and that concepts I have utilized here. Okay, to predict what would be the product. Now let's see the other reaction. Other reaction means here alcohol when react with halogen in presence of red phosphorus. Simply you keep in the mind from OH go from here and halogen attach this. Phosphorus exists in three allotropic form. Allotropic form means the same element exists in the same physical state but in different forms, and hence their properties are also different. So phosphorus exists in three allotropic form, that is white phosphorus, red phosphorus and the black phosphorus, of which white phosphorus is most reactive and black phosphorus is least reactive. So the white phosphorus will be least stable and the black phosphorus will be most stable. So in presence of red phosphorus we take, because white phosphorus very reactive. About the white phosphorus, that is very reactive, possesses chemiluminescent property, means that glow in dark, and that means white phosphorus is poisonous and possesses chemiluminescent property. Other properties is that is most reactive and least stable allotropic form of phosphorus. That was about the white phosphorus. Red phosphorus, that is more stable than that of the white phosphorus but least stable than black phosphorus, and that will be more reactive than black phosphorus and less reactive than white phosphorus. Same concepts but in different ways. Let's see. So here in the presence of red phosphorus, halogen react with alcohol and there is formation of haloalkane. Same here in this compound. Let's see. Among this compound, when react with SOCl2, let's see here this alcohol I have taken. This alcohol react with SOCl2. So SOCl2 like that. Now sulfur here, one oxygen will be doubly bonded, this oxygen doubly bonded, here chlorine and here chlorine. That is SOCl2. Very easy. What happened? This hydrogen will combine with this chlorine, form HCl. This SOCl2. So this chlorine combined to this carbon. SOCl2. Sorry, here I have drawn this wrong. So this one here. So one chlorine combined to this hydrogen form HCl. This chlorine will combine to this carbon and oxygen here this. So this oxygen will combine to SO. So that will become SO2. Listen once more. This is alcohol that reacts with SOCl2. So one oxygen here doubly bonded. The oxygen atom will be doubly bonded with the sulfur and the two chlorine atom will be singly bonded here. The hydrogen of this alcohol will combine with chlorine form HCl. So the oxygen atom that will combine to this sulfur, that means hydrogen chlorine combined with hydrogen, so that become HCl. This oxygen combined to sulfur, so that become SO2. And then after what's left here, this carbon valency left, so this chlorine combined to this carbon. So compound become So when the alcohol will react with SOCl2, there will be formation of haloalkane, SO2 gas and HCl gas. And in this one, when you will prepare by this method, then you will not have to purify the compound, because SO2 is a gas that will escape out. HCl is also gas, so that will also escape out. And in the reacting vessels, only haloalkane will left. Okay. Okay guys, from that was the method of preparation of haloalkane from alcohol. Now let's see the method of preparation from hydrocarbon. So from hydrocarbon, one is chlorination, one is chlorination, this one. So let's see here. So how to chlorination? As for example, let's see 2-3 points. This point is very important for your NEET examination as well as for your IIT examination. Compared to that of 12th board examination, this reaction is more important for you for the NEET examination as well as for the IIT main examination. So what is here? One question, which question asked? Firstly, which questions asked from this reaction? Question asked is for the NEET examination. So for the NEET examination, question simple than that of IIT main, and that is here asked that in this reaction, these reactions takes place through which mechanism? That is, question will be the halogenation of alkane. That means alkane in presence of sunlight will take place through which mechanism? I am not going on the options. Directly I am telling you the answer. So this reaction will take place through free radical mechanism. And in the case of IIT main examination, question will be there. Alkane will react with chlorine, alkene will react, and alkyne will react with chlorine, and will ask which reactions will be most favorable for the formation of haloalkane or whatever be that for the halogenation. That means which among alkane, alkene, and alkyne. In the various forms the question will be asked, but the basic principle of the question will be that free radical halogenation will take place most easily in which case? That is with alkane or with alkene or with the alkyne. So halogenation reaction will be most easy in case of alkane. Okay, because reaction takes place through free radical mechanism. So hydrogen atom in which there is not so much polarity, that will release in the form of hydrogen free radical most frequently compared to that of in alkene or alkyne, where there might be development of positive charge on the hydrogen atom. So let's see whatever with that. So in detail I shall teach you in the separate video special for the IIT main and of the NEET examination. But keep in the mind that who is preparing for the IIT main examination or for the NEET examination, they should watch this one very carefully and starts thinking also. And who is not preparing for the IIT main or the NEET examination, they can escape out that one also. And in CUT examination, just a simple question may ask, that is, this reaction takes place through which mechanism? So this reaction takes place through free radical mechanism. Okay. Second one here is you have to keep in the mind that it is impossible to prevent the reaction in a single step. That is, hallucination of alkane cannot be stopped. Listen here, cause suppose because this one is the lengthy one, so that will take time. But okay, I go through there also by taking this reactant. But if you will apply the brain, then after you will predict. Firstly, I am telling you in the simplified form, that is methane when react with halogen in presence of light. H nu means light. H Planck's constant, nu frequency. So what happens? Halogen will combine with one carbon, so that becomes CH3Cl. Then after again halogen will react in presence of sunlight with CH3Cl. That means some of the CH3Cl molecule will not react, and some of the CH3Cl molecule will again react with chlorine in presence of light, and there will be formation of CH2Cl2. Okay, which CH3Cl molecule will react with chlorine and which CH3Cl molecule will not react with chlorine? That depend on the matter of chance. Now this CH3Cl2 again that will react with chlorine in presence of light. So there will be again one chlorine will combine there. So that become CH3Cl. Again reaction not stopped. Here in presence of light, halogenation will further takes place, and that become CCl4. Okay. So here 2 points you will have to keep in the mind. This reaction, at least 2 points, because who will not prepare for IIT main or for the NEET examination, might be there is a high chances of for those that guys, so that to be he or she be appear in CUET examination. So for the CUET examination also, this reaction is very important, and particularly the information which I am giving you right now, that is quite important. First one is this 1 point. Second 1 point is that is the most important point. And in IIT main and IIT advanced in NEET examination, how the question was asked, about that we will discuss in the videos which will be exclusive for the IIT and NEET examination. Now let's see about this reaction. What happened here? HX is here. So suppose this reaction HI. What happened? In HI, hydrogen is the positive part and iodine is the negative part. So when unsaturated hydrocarbon will react with a reagent, then Markovnikov's rule states that Then the Markovnikov's rule states that the negative part of reagent will bound to that unsaturated carbon atom which will contain less number of hydrogen atom. During addition reaction of unsaturated hydrocarbon, the negative part of the reagent will bond to that unsaturated carbon atom which will contain less number of hydrogen atom. So that will be, so let's see here, in Hi, hydrogen is the positive part and iodine is the negative part. So hydrogen is the positive part and iodine is the negative part. This carbon is unsaturated and this carbon is unsaturated, of which this carbon is containing 2 hydrogen and this carbon is containing 1 hydrogen. In Hi, iodine is the negative part, hydrogen is the positive part. So Markovnikov's rule states that the negative part of a reagent will bond to that unsaturated carbon atom which will contain less number of hydrogen atom. So in this Hi, iodine is the negative part, so that will bond to this carbon and hydrogen to this carbon. So that's why here when iodine will combine to this carbon, so the product will become CH3, CH, iodine attached here and CH3. That means this one. So that's why it is the major product, and when iodine attached to this carbon, so that will be the minor product. Okay. Now addition of halogen, this reaction here, bromine. So 2 bromine here is, that means this bromine and this bromine, 2 bromine here of Br2. So 1 bromine will bond to this carbon, another bromine to this carbon. So that's why vicinal dibromide will form. Okay. So when alkene will react with Br2 in presence of a non-polar solvent, then there will be formation of vicinal dibromide. Okay. About these questions we will discuss later on. Firstly, I am going on all the reactions. Here, halogen exchange reaction. Here, direct fluorination is difficult because reaction will be exothermic. In the same way, direct iodination will be difficult because reaction will be reversible. So what happens here? Firstly, we prepare chloroalkane or the bromoalkane, and then after, to replace by the iodine, we will have to take the iodide of more active metals like alkali metals. So that's why NaI or Ki, iodide of more active metals we will have to take. So what happens? Sodium will combine with this chlorine, form NaCl, and iodine will bond there. So Ri and NaX will form. That is. And for the fluorination, this reaction will be called Finkelstein reaction. This reaction will be called Finkelstein reaction. When iodination we will do, that will be called Finkelstein reaction. Okay. And when we will do the fluorination, that will be called Schwarz reaction. That was Finkelstein reaction, and next one will be when we will do the fluorination, then that will be called Schwarz reaction. So for the Schwarz reaction, we will have to take fluoride of less active metals like silver, gold, cobalt, and so on. So here same fluoride of less active metal has been taken. So fluorine will replace this bromine. So bromine will combine with this silver. So there will form AgBr and this one. Okay, very easy here. Now let's see. No, it will take time for the preparation of haloarenes. About that we will discuss in the next video, preparation of haloarene. Okay, so it's all for this class. In the next class we will discuss about the preparation of haloarene. Thank you, Team Educate.